Hello there, this is Alex Franco and this is my group's presentation of proving Pythagorean's theorem. Pythagorean's theorem states that the hypotenuse squared of any right triangle is equal to the sum of the two squared legs, where c squared equals a squared plus b squared. We will prove this by constructing square IHKM and using this construction to later prove that c squared equals a squared plus b squared. I'm going to show you how to construct this. First, construct a line segment AAC. Then at point A, constructed a perpendicular line ED. Then I constructed line segment IH intersecting both the perpendicular lines, thus creating triangle IAH. Step 4, I measure the distance from A to I by constructing circle AI. Then, using the same radius, I constructed circle HJ. Therefore, we can say that HJ is congruent to AI. Step 5, construct a perpendicular line at point J. Then I measure the distance from A to H by constructing circle AH. Then, using the same radius, I constructed circle JK. Thus, we know JK is congruent to line segment AH, and we have already earlier proved that JH is congruent to line segment AI, and point A and point J are both right angles. Thus we know by side angle side that triangle HJK and triangle IAH are congruent. Step 8. Using the same radius as circle AI, I constructed another circle at point K with the same radius. Thus we know KL is congruent to line segment AI. And then at point L, I constructed a perpendicular line. Then, using the same radius as circle AH, I constructed a circle centered at point L, constructing circle LM, which we can say line segment LM is congruent to line segment AH. We also know at point L, this is a right angle, therefore we can say triangle KLM and triangle IAH are congruent. Thus these three triangles are congruent. Then at step 11, I continued line segment AI through line segment LM, thus intersecting at point O. And then we know line segment OM has the same radius as circle AI, and that line segment OI has the same radius as AH, and that at point L this forms a right angle. Therefore triangle MOI and triangle IAH are congruent. Therefore these four triangles are congruent to each other. Which then brings us to our proof. By construction, we know we have created square IHKM, all with sides of length C. Thus the area of the square IHKM is equal to C squared, or it is equal to the sum of the areas of the four triangles plus the area of the quadrilateral AJLO. We know by the end of step 11 we proved that these four triangles were congruent. If we know the area of one triangle is 1/2 base times height, we can say that the area of these four triangles is 1/2 base times height times 4, because there are four triangles. Therefore that reduces down to 2AB. And then, since these are congruent triangles, we know quadrilateral AJLO is a square with sides line segment AJ congruent to side JL congruent to side LO congruent to side OA, and with all of length B minus A. We can see this because we know AH has a line segment with length B, and that JH is a line segment with length A. Therefore the remaining line segment AJ is the whole thing B minus A. Therefore we can say the area of square AJLO is equal to B minus A squared. which is equal to b squared minus 2ab plus a squared, which we can rewrite as a squared plus b squared minus 2ab. Therefore, the area of the square IHKM is equal to the area of the four congruent triangles 2ab plus the area of the square AJLO, a squared plus b squared minus 2ab. Therefore, c squared, which is the area of the whole square, is equal to 2ab, which we found was the area of the four triangles, plus a squared plus b squared minus 2ab, which is the area of the inner square, which reduces down to a squared plus b squared, thus proving c squared equals a squared plus b squared, which says that the hypotenuse squared of any right triangle is equal to the sum of the two squared legs. Thank you. That is our group's presentation of proving Pythagorean's theorem. See you again.